about to leave, already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free with me. Let's be free with Not looking back, eyes on the freeway, Bonnie and Clyde, a classic cliche. We're on the run, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free.
Good evening, everyone. It's Jim here at Tutor to You, and a warm welcome to the first in a new series of live stream sessions for GCSE Geography. And I'm joined today by two familiar faces. If you've watched any of these sessions before, we've got Brendan on the left and Vicky on the right. Good evening, team.
Hi.
Good evening, everybody, and good evening, Jim.
And great to see you. And I'm just going to turn the sound down on my laptop so I can't hear myself speaking about 5 seconds after I say it. Well, here we go. So it's the first of 10. I think we've got 10 live stream sessions organised this term for GCSE Geography. It's going to be a regular slot here, Thursday night, 6:30. And it'd be great if you're able to join us for, obviously here for this session, but for some of the other sessions as well. If you've not been before, a little bit of housekeeping. It's an interactive session. If you're watching live, then you can use the live chat to type your suggested answers into the chat, and try to give you a call out and a shout out if you're the first to answer, or if your producer put a great response in, or get it right first. We'll look out for those. If you're watching on catch up, and thousands of students watch these sessions in the following days and weeks, you can't use the live chat, but hopefully your answers will be as good. Best way to do it is just to pause the video, have a go at the activities, and then start the video again to see how you do. We've got a mixture of activities tonight, but the format is just very slightly different from last year, where we're going to include some sort of examiner advice, topic updates, that kind of stuff, just for a minute or two as we go through the session, just to highlight the key content that you need to know, by way of a recap, hopefully. And as a consequence, you may want to download the slides of this session to print them off or add them to your notes. Some really good stuff in there in addition to the activities. But I think we're almost ready to start. Are we, Vicky, Brendan? Do you want to get us going? Who's going to start with the first activity?
I was going to start with the first activity.
Here we go. Then have fun, everyone. I'm going to have a go as well, as always.
Excellent.
Go for it.
We have altered vowels. So it's exactly what it says. You need to work out the key phrase, typing the phrase into the chat window if you would like. The vowels have been changed to different vowels. Some of them are really easy. Some of them are slightly more tricky. So Jim, can we have the first one up, please? Okay, so we have faces. Obviously, that's not the correct word there. So what should this word be? So it's something to do with tectonics that you will have come across, hopefully, at some point really early on in that topic. So if you can pop your answer into the chat window, give you just a couple of moments. And obviously, if you're watching on playback, you can just make notes, guess something going on. Okay, we've got some good suggestions coming up. We've got a couple of correct answers. Jim, can we have the correct one, please? Excellent. It is the focus. So hopefully we all know that the focus is the area below ground where the rocks give way during an earthquake. Excellent. Well done. Okay, can we have the next one up, please, Jim? Right, so this is similar in terms of you would probably have covered this in the same lesson. Altered vowels again. So what vowels should they be? You can type out the entire word rather than just the correct vowels, which we had coming up a couple of times. What do we think this is? Excellent. So we already got two great answers here. So Ethan, well done. Hashlene, excellent. You both are correct. It is the epicenter. That's the point directly above the focus on the ground where the effects of the earthquake will be felt the most. Well done. Okay, next one up, please, Jim. Okay, excellent. So next one, you again would have covered this in the first of your tectonics lessons. So for lots of you, this would have been this time last year, maybe even earlier if you started in year 9. Excellent. We've got loads coming up here. So we've got Esther, Ethan, Molly, V, Charlotte, Suzanne. Well done. All correct with plate boundary. Excellent. So this is we hopefully know that the cross is divided into plates. These move around, which we will obviously cover later in this session because the whole session is about those processes at plate boundaries. Thank you very much. Right, next one up, please, Jim. Okay, so again, a couple of moments. What do we think this one is? Okay. Perfect. Already the correct answers coming through. So Charlotte beat everybody there. Closely followed by V, closely followed by Ethan and Mustafa. Well done. So it is a Richter scale. So this tells us the magnitude of the earthquake. It is the most famous scale, although it isn't actually officially used by scientists today. They tend to use the moment magnitude scale, which is a bit more accurate on larger quakes. But you will still see the Richter scale coming up in textbooks, case studies. No. Right, can we have the last one up, please? Okay, this one I think is pretty easy because it doesn't look too dissimilar to the correct word. Okay, I'll just give you a couple of moments. Well done, Ethan, who's got in there first, closely followed by Charlotte. It is the seismometer. So this records the vibrations below the ground. It's used to detect earthquakes. They are often used to detect volcanic activity as well because you tend to get lots of smaller earthquakes with that. Thank you very much. Well done. So that's our first introductory activity done for this evening. So this session we are going to cover the following. We're going to look at a bit of plate tectonic theory. Brendan is going to go through that with you. We're going to look at the global distribution of earthquakes and volcanoes and their relationships to those plate margins, and we're going to talk about the physical processes taking place at different types of margins with a little bit of exam practice towards the end of the session. So I think we're going to have a very quick give me quiz. So Jim, can we get that quiz up? So really easy. Okay, 3 tectonic hazards. You've got 30 seconds. You're not going to need 30 seconds to give me 3 tectonic hazards into the chat, please. Can we have the time? Thank you. So this one is super easy. Okay, we have tsunamis coming up. We have hurricane, which is not a tectonic hazard, but we do have earthquake. So what's the next one? We've got volcano covered as well. Well done, all three in well before that end of the 30 seconds. Thank you. Right, Jim, we can move on to the next one. Okay, so we have breeze coming up there as well. Not quite. Super. So really easy. We have our volcanic eruptions, earthquakes, and our tsunamis. The second one, and our last Give Me Three, is a little bit more tricky, and it's going to be what we cover in the next part of the session. So 3 different types of plate margin. If you can pop those into the chat window, please. Oh, perfect. We've got 3 people already with them all correct. Give you a few more minutes. Oh, sorry, a few more seconds, not minutes. Excellent. You clearly know your stuff. You remember these. Hopefully you remember details about them. Okay, we had so many people getting all of those right. Esther was the first person to get those all correct, followed by Ethan. So we have destructive, constructive, and conservative boundaries. We're going to learn about those this session. So I'm going to hand over to Brendan, who is going to talk you through some of the details about the Earth structure. Over to you, Brendan.
Thanks, Vicky. Right, we're having a look at the Earth structure. Now, this is something that's quite fundamental to our understanding of what's going on with tectonics. But basically, the Earth is divided into layers, and you can see a diagram there, which I'm sure you've seen something very similar to that in your textbook. What some of my students quite often ask me is, how do we know what's going on down there? And essentially, there are various methods, including one called seismic tomography, where they actually can measure using seismic waves generated by earthquakes and explosions to create computer-generated 3D images of what's going on in the Earth's interior. So we can use the arrival times of different seismic waves to define slower or faster regions deep in the Earth. So it's quite a complex thing, and it's kind of akin to what happens if you've ever had an ultrasound, or perhaps when you before you're born, that you may have a scan done of you using ultrasound, so you can see through things to get some idea of what's going on. So it's not dissimilar to that. So the Earth is divided into layers, and the one that we live on, the crust, so it's the most important one from our point of view, is the sort of 40-kilometer thick crust, maybe about 25 miles deep. So it's very, very thin, really, compared to the rest of the Earth. And it only takes up about 1% of the Earth's mass. And it's the outer layer, the oceanic part of it, the bits that tend to be on the seafloor, are thin and dense, and the continental parts are thicker and lighter. And that means that it's a little bit like the difference between different types of chocolate. If you've got a really solid bar of chocolate, that's like the oceanic plates, whereas the continental tends to be a bit like those, I don't know if I should product place here, I'm certainly not getting paid by them. Aero is a bit like the continental plates, where they have a little bit less density going on. So what happens is that when they meet, the continental plates tend to sort of float above the oceanic plates. So beneath the crust we have the mantle, and that's a very tricky sort of area. It's not one continuous layer. It's thought to be made of at least 2 or 3 different parts. And it's basically rocky material that has some fluid qualities, which means it moves, but it moves very slowly. You wouldn't really say that it flowed, but it does move very slowly. And some scientists have compared the qualities of the mantle to something a bit like silly putty, where the behavior of the rock depends on factors such as pressure, temperature, and its chemistry. Inside of that, we have the core, which is 2 sections. So it's extremely hot. It's like some parts of it are thought to be as hot, if not hotter than the sun. It's under huge amounts of pressure. We have the inner core, which is pretty much solid, and the outer core, which is more fluid, and it's largely responsible for creating the Earth's magnetic field. So we have all these things going on. So the bit that we're most interested in from GCSE Geography point of view is that crust and upper ridge part of the mantle that form the lithosphere. and that's divided into these chunks called plates. So if we look at plate tectonics theory, scientists are still not completely sure about what causes tectonic plates to move. There was a phase when they were confident. I think that confidence has kind of declined a bit. And we do think it's a combination of convection currents and also something called ridge push and slab pull. So we're going to elaborate just a little bit on those next. Ridge push means that at the constructive margins where molten magma is rising up, the plates are kind of pushed apart. And this is going on at places like the Mid-Atlantic Ridge. And then it cools to form new plate material. And as it cools, it creates underwater mountain ranges. So this is going on the sea floor, remember. And the ocean ridges can be up to 4,000 meters above the surrounding ocean floor. So I mentioned the Mid-Atlantic Ridge. The one that runs down the Mid-Atlantic was discovered, in fact, about the middle of the 19th century by the first people laying cables across the ocean floor. And they noticed that in the middle of the Atlantic, the sea floor wasn't quite as deep as it was elsewhere. And it wasn't until about 100 years later, the sort of 1950s and 60s, they discovered what was causing this, and it was this ridge that was being created by the upwelling from beneath. And that's really important because it pushes away material on either side, which by that time has become solid and cool. And it slides down away from the ridge as it becomes more dense, and it pushes the plate in front of it. Then we have the next section, which is slab pull. So at destructive plate margins, we have a different kind of process going on where the oceanic plates, which are more dense, have to go under the continental plates. They have no choice really because they're more dense. And those plates are then subducted. The oceanic plate is subducted into the underlying mantle, and it's kind of pulled down by its own weight, and it pulls the rest of the plate with it. And we think that sometimes the leading edge of those plates actually falls down slowly but surely into the mantle and is recycled. So some scientists think that slab pull is the most significant process driving plate movements. So over to you, Vicky.
Vicky, do you want to unmute yourself for this one?
Sorry. I don't normally mute myself, which is the issue there. So we're going to look at the three different plate boundaries that we have taught, that you will have learnt about. I'm going to talk to you first about those constructive plate margins. These are plates that move apart. So typically about 2 centimetres a year. This can vary. That's kind of an average there. And the margin between the North American and the Eurasian plate is an example of a constructive plate margin. So at these margins, the upper part of the mantle melts, so the hot magma inside will rise up. The tectonic plates here will then move apart, and the molten magma rises in between, and it cools down to form some solid rock. However, this solid rock can actually fracture, which causes earthquakes, usually quite shallow, and they're usually fairly low in magnitude at constructive plate margins. Most of that magma won't actually reach the surface, but it might push up the crust to form a ridge. So we have like famous ridge like the Mid-Atlantic Ridge that we've already talked about this session. And hopefully you will know that that Mid-Atlantic Ridge is the one that goes straight through the middle of Iceland. When the magma does actually erupt, it produces very runny lava, which spreads out. It spreads out before cooling, which will eventually form a shield volcano. And hopefully we remember that shield volcanoes have a really wide base, and they have really gentle slopes. Okay, so we need to remember at those constructive plate margins, those plates are moving apart. So I'm going to hand over to Brendan now, who's going to talk you through destructive plate margins.
Thanks, Vicky. So let's have a look at destructive plate margins. What we've got going on here is that two plates are actually moving towards each other, and we often say that they're converging. So sometimes destructive plate margins are a type of converging plate boundary. And because the oceanic plate will be more dense, it sinks beneath the continental plate. As it does so, it gets pushed down and ends up partly under its own weight due to slab pull, gets pulled down into the mantle where it gets recycled. But that process is not a nice, smooth process. Often the plates get stuck for sometimes many years, and then they jolt forward very suddenly, and you can get really severe earthquakes occurring at these places, and sometimes they will cause tsunamis as well, where the continental plate has been pulled down a little bit and then it springs back up, creating something, like a really, really strong mega thrust earthquake. And there have been several examples of those in the last 20 years or so. So this is what's going on at a destructive plate margin, where the oceanic plate will then be subducted underneath the other one. Sometimes along these margins, you will also get a line of volcanoes emerging on the continental plate together with fold mountains. And a very good example of a place where this is happening is, as the example shows here, on the boundary between the Nazca plate, an oceanic plate, and the South American continental plate along the western side of South America. And over to Vicky. We're going to look next at conservative plate margins.
Excellent, thank you very much. So at conservative plate margins, we have those plates moving parallel to each other, so moving side by side. So the Pacific and the North American plate are a good example of that. Sometimes they're moving in the same direction, sometimes they are moving in completely opposite directions. So the Pacific and the North American plate famously has a San Andreas fault line running through it, which is happening at that conservative plate margin. So these plates, if they're moving opposite, obviously they can get caught up between each other. If they're moving side by side, they will move at different speeds. Now, as they're moving side by side, you get the process of friction building up. This causes them to stick. Over time, that is going to build up quite a lot of pressure, which can lead to a sudden release in the form of an earthquake. So a sudden release of energy, breaking up those rocks below at the focus, obviously setting off that enormous earthquake. There are no volcanoes along conservative plate margins because we have no magma involved. There's no magma rising, so there's nothing to actually cause those volcanoes to happen. So hopefully we've given you a little bit of an overview of those 3 plate margins and the processes that happen here. So what we're going to do now is we're going to do 2 activities to test your knowledge. So I'm going to hand over to Brendan for a connection wall, and then I'm going to do some true or false questions with you.
Hi, Brendan. Your turn to mute now. Unmute.
Thanks, Jim. I was just talking to myself there for a minute. It's never very sensible. So connection wall is very similar to a TV program you may have seen, which has the word connect in it. And there are 12 terms which can be grouped into 3 groups of 4. So we're going to present them to you now, and you've got to try and identify what the 3 groups are. So there's 3 groups of 4 things. So spend a moment looking at the grid and see if you can identify what the first of the groups might be. So I can offer you one clue, which is that it is going to be one of the different types of plate margin. So it's a follow-up to what we were talking about a few minutes ago. So would there be a particular plate margin where 4 of those things have something in common? So jot your ideas into the chat and see if you can suggest which one might be the case.
It's probably worth pointing out here that if you're watching on playback, obviously you can pause it and give yourself a little bit more time, because we realise this is quite a tricky ask in a short period of time.
Absolutely, absolutely. So perhaps if we reveal the first one and then the others might kind of fall into place. So the first group would be things associated with constructive plate margins. So such as the Mid-Atlantic Ridge, the fact that the plates are moving apart. A good example of where this is happening is the Eurasian and North American plates, and you will sometimes get shield volcanoes emerging along these margins. You do get shield volcanoes in other places as well at hot spots too, we should point that out. Okay, let's see if we can spot another group. There's 8 items remaining, 2 groups of 4. I think Robert's got this, well done. Let's have a look at the next group. Destructive plate margins. this would be where you've got two plates moving together. So in this case, a good place where this can be observed is between the Nazca and South American plates. The oceanic plate at destructive plate margins being subducted. So you've got subduction going on. They're obviously moving towards each other, moving together. And one of the symptoms of this, if you like, or one of the causes of this, or not the cause, but one of the impacts of this would be you get not only very severe earthquakes, but also composite volcanoes. And let's look at the last group. You can see the four which are remaining. So it's just a question of identifying what they've got in common.
So on the chat window, Esther and Torbit have actually connected 4 of these. Do we know which plate margin they go with?
Okay, let's have a look and see. These are indeed conservative plate margins. This is when plates are moving side by side or alongside each other. Sometimes they're moving in the same direction, but at different speeds. And that's happening with the Pacific and North American plates. One place where this is famously happening is the San Andreas Fault. And there won't be any volcanic activity here because there's no particular reason for the magma to escape, if you like. So volcanic activity is very, very rare along these margins. Okay, let's move on to true or false. Back to you, Vicky.
Okay, well done those guys of you who did notice that was conservative before we put it up on the screen. So we have 5 quick true or false statements for you again, based on what we've just been talking about about those 3 different margins. So you just need to pop a T or an F into the chat window. So our first one, tectonic plates move side by side at destructive plate margins, true or false? So hopefully these should be really easy now. Super. The consensus seems to be that that's false. Can we just check that they are correct, Jim? Perfect. Well done. Okay, next one, please. So does tectonic plates move towards each other at destructive plate margins? We've got lots of falses coming through, but I think that's probably left over from the previous question. Excellent. So lots of trues coming through here. So yeah, we've just talked about that. We've just talked about those plates moving towards each other in the process of subduction. Excellent. When you get to continental plates moving towards each other, you actually get them pushing up. So you get fold mountains that we briefly mentioned earlier. Okay, next one, please, Jim. Tectonic plates move away from each other at conservative plate margins. Is that true or false? Okay. So we've got a mixture at the moment. So we've got some people who think it's false, some people who believe it's true. So can we get the correct answer up on the screen, please, Jim? So it is false. Okay, remember they're moving side by side. Okay, next question. Earthquakes are found at destructive plate margins. Hopefully this is a nice easy one. Okay, and we've got lots and lots of people already saying that is true. So let's just check that you are correct. Super, well done. And our last true or false statement is volcanoes are found at destructive plate margins. Is that true or false? Excellent. Again, all coming through is true. So remember, we just talked about this. So destructive and constructive plate margins have volcanoes. Conservative don't, because there is no magma involved there. Right, so one feature of these new study streams is that we're going to focus a little bit on exam practice. So each week we're going to show you an exam, sort of a typical exam question. We'll talk you through it. So I'm going to hand over to Brendan for this activity.
Thanks, Vicky. So here we have an example of exam practice with a diagram. You would quite often get something like this, which we call a stimulus part of the material, to get you thinking about things. And then you are expected to answer a question about it by adding value, showing your understanding and applying it to the diagram that you can see. So in this case, it's a destructive plate margin. And your task for this question would be to explain the physical processes that happen at destructive plate margins. let's look at the command word first of all. It's to explain. So you have to say in some depth what's actually going on here to give reasons why this is happening. So if we look at the next slide, we can pull that apart a bit and we can start thinking about what happens when, remember, oceanic and continental plates meet. The oceanic plate is more dense than the continental plate. The continental plate is less dense. When they meet, the continental plate goes up over the oceanic plate goes under it. The oceanic plate is then subducted underneath the continental plate. And then if we move on, the examiner wants to see that you are using a range of key terms, key vocabulary really well, that you understand what the terms are, to show that you understand those key physical processes at work. So you could include things like the fact that fold mountains might be created at these locations. This issue of the oceanic plates and their differential densities. The oceanic plates are more dense, continental plates are less dense. That's a really key idea there. And you get very severe earthquakes happening there. The depth of the earthquakes is important too. They tend to be quite deep, but the shallower ones, the ones that are slightly less deep, are more damaging. And then you could also explain why volcanicity happens there, especially composite volcanoes, and demonstrate that that's the type of volcanicity that would happen there. Okay, let's move on.
Okay, so our final activity this afternoon is a quick 10-second countdown. We've got a couple of questions for you based on some of the things that we have covered today. So, Jim, can we have the first one up, please? So the magnitude of earthquakes can be measured by the Richter scale, which is a logarithmic scale. Simply, we want to know, what does that mean? So if it's a logarithmic scale, what does that actually mean? You have 10 seconds to answer that question. So if we can have the timer up, please, Jim.
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Excellent. Some good answers here. So it's the value is magnified by the power of 10 each time. Well done. If we can get that up on the screen, please, Jim. So we have that it indicates a 10-fold increase of power. So, for example, an earthquake with a magnitude of 7 is 10 times more powerful than one with a magnitude of 6. Can we have the next question up, please? Right, so time to get your maths brains out. I know it's a bit late. How much more powerful is an earthquake with a magnitude of 8 than an earthquake with a magnitude of 4? Okay, we have 10 seconds to try and get the correct answer. So can we have the timer, Jim?
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Consensus in the chat window. Can we just check whether that's right, Jim? It's actually 10,000 times more powerful. Remember, it's 10 times 10 times 10 times 10. So hugely more powerful. Last question, please. This is a nice, easy question, I think. Hopefully, if you have been listening, we've talked about this a couple of times now. So which type of plate margin is not associated with volcanic eruptions?
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Super. So everybody who has answered in the chat window so far has got this one right. It's conservative. Is because of the no magma. But actually also at convergent margins where two continental plates meet, because there is also no magma there either. Right, thank you very much. Jim, can we just have the next slide? Thank you very much for joining us on our first live stream session. Hopefully it's been useful, and hopefully it's made you remember some of the things that perhaps you thought you had forgotten. There is lots and lots more support available on the Tutor2U website, lots of resources, there's study notes and revision support available. So you can either follow the QR code which is on the screen, or you can log on to tutor2unet.net and search for geography, search for GCSE, all sorts of things on there to help you with your studies. Yeah, and thank you once again. Please join us next week. We are looking next week at tropical storms, how they form, where they form, and why. Should be a good one, hopefully.
Fantastic. Can we not do that now? We've got half an hour spare.
I'm really hungry. I need to go and eat some dinner.
Can't we binge watch these live streams and do like we do on Netflix?
Obviously you can.
Fantastic. Brendan, Vicky, that was really good. Many thanks. A huge thanks to everyone who's joined us live. I mean, just the answers there were phenomenal and so quick as well. I mean, it was amazing. I would say, I might be wrong in this, Brendan. Vicky, tell me if I'm wrong, but I think that's the best live student audience we've had at the GCSE Geography live stream this term, I would say.
Yeah,
Definitely
it definitely is for this term. Absolutely.
Right up there. So well done, and hopefully if, the live audience have set the bar. If you watch on catch up, you've got a lot to live up to, but hopefully you get a chance to not only just to have a go at the activities, but also that fantastic overview of the topics that we were covering tonight. Really useful for revision. What I'll do when this session ends, if you go to tutor2u.net/live and go to this session on there, you'll be able to see a recording of that, but also you better download the slides. So, for example, you want to print off those fantastic summaries that Brendan and Vicky went through. Maybe print them off, add them to your notes, and I'll also pop some links on some other stuff on there that you can use to help recap and revise this topic. If you've enjoyed the session, as always, we never take this for granted, but we do ask you give it a thumbs up on YouTube, just to help YouTube suggest this content to other GCSE geographers who maybe had other things on tonight but would find the session useful. And well, yeah, we've got a date, haven't we? It's Thursdays at 6:30 in term time, not over half term. And so we're looking forward to next week's session. Hopefully you can join us for that. Spread the word, and we'll see you next week. So thank you.
Excellent.
Thank you.
All the best. Thank you.
Yeah.
Bye.
Bye.